Today we're turning the beach into our outdoor lab, because if there's sand and surf, there is definitely science. We're going to do 5 fun experiments: sandcastle strength, closer look at sand, sand temperature, salinity density tower, and the seashell sound experiment. If you would like to get a 1-page cheat sheet of the experiments we're about to do with pictures that you can print, send an email to the address below. Okay, let's dig in. First up, the sandcastle strength test. We're going to make 3 sandcastles with different amounts of water, starting with the dry one. Flip the mold. Now for the strength test. We'll stack rocks to see how many of them they can support. For the dry one, not even one rock. Okay, let's wipe the slate clean and try again with a damp mix. A little bit more water, lots of packing, flip, and gently lift. All right, 1, 2, 3, 4, and fail. Well, that's better. One more try with even more water, the soggy version. Pack it in, flip, and testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, and no, that's all. Soggy sand is the winner. When you add water to sand, the molecules loosely link together in a process called cohesion. The H2O water molecule forms these chains that help prop up the grains of sand. More water molecules means more support. What if we add a little crushed limestone into the mix? Commonly called lime. Do the regular deal. Pack it down nicely, flip, and now the test. 12 stones before failure. Wow, adding lime really makes a difference. Why is that? Lime plus water creates a chemical reaction that produces calcium hydroxide and heat. Lime acts as a superglue to hold the sand particles more strongly in place. They are the primary components in cement. That's our first physics lesson right here on the beach. Let's have a closer look at that sand in our sandcastle. What's in here? Most of this is ground up quartz. Silicon dioxide smashed by wave action over millions of years. It comes in different colors: white, pink, green, black. Some of these black grains look different. I wonder if it's iron or magnetite. Let's find out. Here's a powerful stack of magnets. We'll probe the sand, swirling to get maximum exposure. We'll rinse in a little water to get rid of the clinging white sand. Nice. That's bits of iron and magnetite. And now a quick peek under the microscope. Fascinating. Now let's move the magnet slowly around the sample. The iron bits line up like little compasses. Pretty cool. Do you know what happens to sand when you heat it up? I mean, really heat it up? We'll save that experiment for the end, so stick around. It's very cool. Is black sand hotter than white sand? Let's find out. Here on white sand, the temperature is 81 degrees. And on black sand, it's 88 degrees. Black sand is indeed hotter. White surfaces in general reflect more light. They're brighter because more light reaches your eye. In this example, some of the energy is absorbed by the white chair as heat, but darker surfaces absorb more solar radiation and store more heat energy, so they're hotter. This is solar radiation at work. Choose the white sand path to get to the water so your feet don't sizzle. Next, let's do the salinity density tower experiment. Yeah! What happens when salt and fresh water collide? In the first test tube, we're going to add bottled water and a little red food coloring to see the layers clearly. Just seawater in the second test tube, more seawater in the third test tube, with some blue dye, plus extra salt. This will give us a third density. Shake vigorously so the salt dissolves. If you don't have test tubes, plastic cups work just fine. If you pour carefully, you'll see layers, like a science parfait. Start with the blue, that's the easy one, the densest in our saturated blue water, or about a third of the way up. Next, regular seawater, but Use the back of a spoon to disperse the flow so the water enters slowly and doesn't disturb the blue layer too much. This is a little tricky. And finally, the red regular water. It has no salt and has the lowest density and will stay at the top of our science parfait. Yeah, we did it! Increasing density from top to bottom so the layers separate. You just witnessed density stratification. Even more fun when you do it yourself. And finally, what's the deal with the ocean in a shell? What do you actually hear when you put a shell up to your ear? We'll record the sound with our phone. Simple app like voice recorder will do the job. Try it near the ocean. Away from the ocean. And do a sample really far from the ocean. As sound waves enter the shell, different frequencies either die or resonate depending on shell dimensions. That produces the distorted sound. Any nearby sound will cause this effect. You can try it at home using a simple cup. There you have it. 5 experiments you can do with 0 lab coats. Just flip-flops and curiosity. Science is everywhere, even in your sandcastle. Now for the bonus experiment. What happens to sand when you heat it up? I don't recommend that you do this experiment yourself, but if you do, wear protective gear. Cover your skin, protect your eyes, and do it in a ventilated area away from flammable materials. White sand needs 3,000 degrees Fahrenheit to melt. We're mixing in some soda ash to lower the temperature a little and make it easier. A torch using MAP gas and oxygen can reach that temp. Let's see what it can do. Sand is silicon dioxide, 1 atom of silicon and 2 atoms of oxygen. So is glass. It's working! Now we let it cool for a while. Let's see what we have. Definitely fused together. Let's take a closer look. Yep, it's definitely glass. Melting sand at 3,000 degrees Fahrenheit turns into glass. Thanks for watching to the end. To get a 1-page cheat sheet on how to do these experiments with pictures that you can print, send an email to the address in the description below. It'll make your next beach visit even more fun.